Okay, hi everyone. Hopefully you guys had a good week. We're going to work on, again, limits, back to limits. And we are going to do today limits, again, limits at a vertical asymptote. And on your last IXL homework, you guys were just looking at graphs that were already drawn. Let's give you guys something kind of lame. Y is equal to 1 over x. Okay, so that graph looks something like this. Going to infinity, going to infinity. Now, we could have talked about a couple of rules when we're looking at this. First, if I start off with just the equation, we know we had a vertical asymptote when x equals to 0, because you can't divide by 0. And I came up with an idea before. If I divide by 0, this is really, we call it undefined, but it really is, in essence, infinity. Now, is it positive or negative infinity? We don't quite know, but how many times does 0 go into 1? An infinite many times. If I mention my last example of slices of cake, if I ask for a slice of 0 of a cake, how many slices can you give me? An infinitely many set of slices. So what we see in the graph is that's actually what happens. As x approaches 0, we shoot off to infinity here, or negative infinity. Now, these types of questions, the fastest way to do them is actually just plugging in a number. If I just look at 1 over x, and if I plug in 0.01, that's like a penny, isn't it? Now, would that make the fraction a positive or negative fraction? It would make it a positive. So if I plug in 1 over 0.01, this will be positive. And turns out, as I get smaller, as I get smaller, 0.001, 1 over 0.0001, as we get closer to 0, this just becomes a bigger positive. So without doing any work, we can get a feeling that the limit as x approaches 0 from the right side of 1 over x goes to positive infinity. And this is what we're going to look at today, this behavior, that I don't really have to do the math. I just got to, have a feeling. Is that going to be a positive or a negative fraction? And as I get closer, that fraction is going to bloom up to infinity. If I look at the left side, if I look at, let's do 1 over x again. And this time I'm going to plug in a value on the left side of 0, negative 0.01. So this would be 1 over negative 0.01. That's pennies. How many pennies are in a dollar? 100. This will give us negative 100. If I say 1 over negative 0.001, that's going to be negative 1,000. That's even more negative. So without really using a calculator, doing any work here, we can see that from the left side, the limit as x approaches 0 from the left side is going to be negative infinity. Now, is it that simple? And the answer is yes. It's that simple. Because I'm going to change this problem slightly, and we're going to see it's still going to follow the same model that we just did. So if I write the problem, 1 over x minus 3, that's my graph. Okay? And of course, you could waste time graphing it. 1 over x minus 3, that means we have a vertical asymptote at x equals to 3, because that gives us our 0. If you follow our graphing rules from pre-calc, we know the horizontal asymptote, since the bottom denominator, x is larger, it's going to go to 0. I'll go 0. Mr. Ko, how did you know that the right side was going to go on top? Plug in a number quickly. If I plug in 3.1, that's on the right side of 3. Will this give me a positive or negative fraction? 3.1 minus 3 would be positive 0.1. And a positive divided by positive, let me write out my thought. 1 over 3.1 minus 3 would be 1 over a positive 0.1. That means it's going to be a positive 10. So I know I'm going to be above my horizontal asymptote here, positive 10. And if I continue the trend, 1 over 3.01 minus 3. Well, that's going to be, again, another positive, which gives me now 100. So my goal is to say, hey, by just looking at the problem, and we're approaching 3 from the right, and we're going to approach 3 from the left. By just looking at the problem and getting a feeling, could we say which way we're going, to positive infinity or negative infinity? Looking here on the right side of x minus 3, where 3 is my vertical asymptote, I'm going to end up with a positive fraction. So it's going to be positive no matter what. It's going to be 1 over a positive number. Well, that's going to be positive infinity then. Let's look at from the left. If I put something like 2.9, wouldn't 2.9 be smaller than a negative 3? That means this is going to be 1 over a negative fraction. And a positive 1 divided by a negative will always lead me to a negative number. And it can't be as simple as that. By you just throwing in a number to the right or to the left and then making a judgment call. Would that be a positive or negative fraction? And that would lead us to an infinity, a positive infinity or negative infinity. So we're going to move on to a little more slightly complicated example, but it totally follows the same pattern. Let's use blue. We're going to say y is equal to 1 over x minus 2 and x plus 1. Okay, so now this graph has two vertical asymptotes, one at -1 and one at +2. So if you remember how to graph this in pre-calc, and you might not, we first graph 1, the vertical asymptotes, and then 2, we graph the horizontal asymptotes, or we can say where they're going. So the horizontal asymptote here is the idea it's 1 over x squared, which means the bottom is bigger. So horizontal asymptote is going to be 0. This leads the horizontal asymptote to be 0. If you're not sure how I did that, just plug in larger numbers. 1 divided by 10 is 1/10. 1 divided by 100 squared is 10,000. That's even smaller. 1 divided by 1,000 1,000 squared is like 1,000,000. So 1 over 1,000,000 is pretty much 0. Okay, so if the bottom is bigger, it leads you to a smaller number. That's why it goes to 0. So we know we have a horizontal asymptote at 0. Now, we're really just plugging and guessing. If I pick a number on the right here, let's pick the number 3. Would 3 fall on top or on bottom? Would 3 fall on top or on bottom? Now, how do we make that choice? Just plug it in here. If I choose 3, 3 minus 2 is positive. 3 plus 1 is positive. A positive divided by positive means you are stuck on the top of this graph. Let's go on the left side. I remember this is -1. Pick a number on the left side of -1. -2. Sure. If I plug in -2 here, -2 and -2. -2 minus 2 is -4. So it's 1 over a negative sign. And -2 plus 1 is also negative. But negative and negative become a positive. That means we are on top. And since we don't have any zeros in the middle, we're going to be stuck either on top completely, on top, or on bottom, because we have no roots there. Looking back at pre-calculus, if there was a root, we would cross over through that root, and it would just depend which way we would cross by plugging in values. So let's see what that would look like by just, again, plugging in a value in between now, -1 and 3. If I plug in 0, please choose 0. Please choose 0. 0 is the easiest number there. 1, if I plug in 0 and 0, we end up with 1 over negative and 1 over positive. You could say -2 and +1. Sure. 1 over -2 and +1. That gives us 1 over -2. We're down here. So we know the graph is going to go this way. why doesn't the graph flip? Why doesn't it do this S shape? Because if you remember in pre-calc, you need a root. And if we have no roots on top, well, the top goes to 0, we don't cross that x-axis. So no roots, that means there's no borders for us to go right on through. Okay, let's continue this conversation. So what would the limit look like? The limit as x approaches 2 from the right side of, well, we'll just say this is, I'm going to call this f of x to save my life, save my time writing. It's going to be f of x. Okay, what would the limit look like as we approach x from the left side of f of x? What would the limit look like as we approach x from the right side of 1? And what would the limit look like as we approach x from the left side of 1? Okay. So to talk about this, let's just plug it in. Looking here. So we could look at the graph. The graph is done. Look at the graph. The answer here from the right side of 2, that's going to be positive infinity, right? We're going to say positive infinity there. From the left side of 2, that looks like negative infinity. From the right side of 1, that looks like positive infinity. From the, negative infinity. And from the left side of -1, we're going to see positive infinity. So looking at the graph, you guys did this in IXL, 100% all around. But what can I do if I don't have a graph? You could have graphed it like I said, but this is 100% waste of time. 110% waste of time. So I want you guys to get that feeling again. If I plug in a value larger than 2, 2.1, 2.2, would x minus 2 be positive or negative? Bigger than 2, this will be positive and positive. This for sure is a positive fraction. We're going to positive infinity. If you want to do that by plugging in numbers, 1 over, let's plug in 2.1. 2.1 minus 2 is 0.1. And x plus 2 is 3.1. And 1 divided by 0.31 is going to be a big number. It's going to be like 3. Ooh. But if we get 2.01, as we get closer to 2 from the right, this fraction is going to balloon up. And it's going to take us to positive infinity. Let me pause here. So now that we did the plus side, let's do the, well, not plus side, the right side, let's do the left side. So I'm going to rewrite it down here so you guys can see it. X minus 2 and x plus 1. So if I pick a number on the left side, like 1.99 is really close to 2, but from the left side, from the left side. Well, if I do that, we realize that we can make the symbols of this would be negative and this would be positive. And a positive divided by negative and a positive, this is going to be a negative for us. So we know this is going to go to negative infinity. Now, how did I know this? First thing, remember, if I plug in 2, it's a vertical asymptote. We're going to end up with 1 over 0. If I plug in 2 and I plug in 2, 2 minus 2 is 0. So we know that was probably going to be an infinity already. Now, which infinity is it going to be? By testing the water, by sticking our big toe in the pool, we know it's going to be a negative. Testing the water without really plugging any values in. We can do exactly the same thing for the 1. That's right over here. X minus 2 and x plus 1. Now, look here. The 1 doesn't bother the 2 anymore. It's going to bother this guy here. Because if I plug in the 1, no matter what, that negative 2 is going to be bigger. It's going to be negative. So for sure, if I plug in the 1, that's plugging the 1 from the right. Pick 1.1 if you want. 1.1 and x minus 2 will always be negative. So this will be 1 over negative. And if I plug in a 1.1 to, oops, yeah. Oops, sorry. This is a negative 1, I'm sorry, negative 1. Right, that was a negative 1. Negative 1, I'm sorry. Didn't write it there. That's a negative 1. If I plug in a negative 1 here, for sure it's going to be always negative, like negative 3 now. On the right side, we're going to plug in on the right, it's going to be, making sure I got this part right this time. I'll plug in a number on the right of, just to show you guys a number line, in case you guys can't visualize it. Here's my number line. Here is 0. Here is negative 1. A number on the right side is negative 0.99. A number on the left side will be negative 1.01. So on the right side, if I plug in negative 0.99 here, what's going to be bigger, the negative 0.99 or the 1? Well, the 1's going to be bigger, and this will be positive. So looking at this fraction here, I see it's a positive 1 on top, and I see a negative and a positive on the denominator. This is going to be a negative infinity. Again, to reiterate, we have a positive on the top, and we have a negative on the bottom, as well as a positive. We still have one negative. This is going to be a negative fraction. Take a look at the graph now. Does this correspond to what we said? On the left side, let me erase some of this stuff. On the left side, as we approach negative 1 from the right, we go toward negative infinity. So without having the graph, we can figure out which way it should go. Okay, let's go from the left side. So a left side number of negative 1, we mentioned, is going to be negative 1.1, negative 1.1. That's from the left side. So let me write the fraction now so you can see it. X minus 2 and an x plus 1. If I plug in a negative 1.101, this is still going to be negative. We know that's going to be like negative 3 now, negative 3.01. This was a lost cause. We're worried about the other factor. If I plug in negative 1.01 compared to a positive 1, are we going to be more positive or more negative? We're going to be more negative here. So this fraction looks like a positive over a negative and a negative. A negative and negative become a positive for us. Turns out this is just plus infinity. Again, we know it's going to be infinity. We just don't know which one. How do we know it's going to be an infinity? Is because if I did plug in 1 over negative 1, oops, let me write this a little better. Negative 1 minus 2 and negative 1 plus 1, this was going to be 0. We ended up dividing by 0. 0 over a number is going to be infinity. It's going to be positive infinity or negative infinity, depending which way you swing. And in this case, if I swing to the left, if I swing from the left side, it was going to actually be positive infinity. Looking at the graph that we drew, we actually go to positive infinity here from the left side of negative 1. Okay, now let's do one more quick example. I want to make this trash. Okay, here we go. This one looks, oh, wait, let me pause. Give me a second, please. Okay, let's do one more example of vertical asymptotes. And this time we're not going to graph at all. I'm going to write x plus 2, x minus 1, and x plus 3. I want to ask you guys, what is the limit as x approaches negative 3 from the right? And we'll call this again f of x to make my life easier. You could write y, right? Oftentimes they write f of x. And then the limit as x approaches negative 3 from the left. We're going to do the same thing over here. The limit as x approaches positive 1 of f of x from the right. The limit as x approaches 1 from the left of f of x. And then the last one is, what's the limit as x approaches negative 2 of f of x. Okay, just throw a third one in, fifth one in there. Okay, so our goal is to do this without graphing and as fast as we can, and just with a feeling, right? I wish I had background music to play right now, but YouTube will probably do something about that. So we're going to go ahead and say, sorry, Andrew. All right, here we go. So -3, if I plug in -3 here, -3 here, and -3 here, you would agree the top is not 0, that's not 0, but this is 0, so we end up with a number over 0, right? Okay, so we know, is this indeterminate? Nope, this is undefined. This is infinity. Which infinity is it? I don't know. So what I'm going to do here is I'm going to go ahead and plug in a number slightly to the right side. So if I plug in a number on the right side of -3, here's my number line just to help some of you guys see this. Here's 0, here's -3. So -2.99 is on the right side of -3, and -3.01 is on the left side, because this is a -3. If I write 2.99, -2.99 here, okay? And -2.99, okay? You don't have to write it, but you have to like feel it. You have to kind of get the idea here. What happens to all the signs? The top, -2.99 plus 2 is going to be negative. You guys agree with me there? -2.99 right here, that's going to be still negative. But -2.99 and 3, that's going to be actually positive. We have negative, negative, positive. It's going to be a positive infinity. That's how much work we need. It's just a feeling. And I can guarantee you it will go to positive infinity. We know it's a vertical asymptote at -3, so we know it's going to be plus or minus infinity. Which one is it going to be? From the right of -3, it will be positive infinity. Let's do the same thing now for the left side of -3. So the left side we said was going to be something like -3.01, -3.01, -3.01. I would like to cue you in on something. Did any of the other signs change except for the x plus 3? -3 plus 2 is still negative. -3 minus 1 is still negative. Those don't change. We're actually only affecting the factor that goes to 0. And on the left side of that, if I stick in -3.01, that's going to be actually negative. So a negative, negative, negative leads me to a negative infinity. No work, no drawing. And you guys can actually do this in your head. You can say, okay, -3 plus 2. Okay, that's negative. -3 minus 1. Oh, that's -4. Still negative. -3. Oh, more negative than 3. That's negative. Done. No work, no writing. To show work, you really want to just do this to make sure you got it right, like in your brain. But it means sometimes we miscount the number of negatives and we mess up. So that's why I like writing it out. Okay, let's go to the next one on 1 from the right. So if let's draw this out. You might not need it. I'm going to try it out though. Here, number line, here's 0, here's 1. And on the right side, 1.1 and 0.99, okay? Or just 0.9, okay? Just a feeling. Doesn't have to be super decimally, okay? But if I use this number over here on this fraction, what type of feeling do you get? On top, if I plug in a positive 1.1, right? Or positive 1, that's not going to matter with 2. If I plug in positive 1.1, ooh, that would matter with this factor. And 1.1 doesn't matter with 3. This would be a positive on top over a positive on bottom and a positive again. So this is for sure positive infinity. Guarantee you that. I'll get on T. Positive, positive, positive. They all look positive to me. And know what? The next one, if I use from 1 on the left side, 0.9, if I plug in 0.9, 0.9, and 0.9, these don't change. They're still going to be positive. So don't waste your time. Just make sure you know they're positive or negative from before. But the factor that was on that borderline of 0 is going to be more negative here. 0.9 minus 1, that's more negative. And that really changes everything, changes the tone. Negative infinity. So now what about the limit as we approach -2? Now I'm going to write it here. Let's use blue again. So it's x plus 2 over x minus 1, x plus 3. We've been saying infinity so many times. But remember, limits, you should always try plugging it in. And if I plug in -2, -2, and -2, what's -2 plus 2? That's just 0. 0 over who cares? Because as long as these aren't 0, I don't care, right? If my wallet has nothing in it, how many tens do you have? 0. How many hundreds do you have? 0. 0. And that's 100% okay answer. If it's 0 over a number, the answer is not undefined, it's not indeterminate, it's just 0 from Algebra 1. And kids, they're like, oh man, what is 0 divided by 3? Gosh, what's 0 divided by 3? It's just 0. We've been looking at 0 in so many ways. Don't forget, if it's 0 over a number, that is just 0. That's a perfectly wonderful answer. And this graph actually has a root at 0. Okay, wait, sorry, 0 at -2. That's the root. 0. We have a root at -2. Now, knowing these trends, you could graph the graph fairly easily. So if we want to graph, we know we have a vertical asymptote at 1. We know we have vertical asymptote at -3. And we also have a root at -2. Okay? I see this as x on top over x squared on the bottom. We have a larger denominator. So as this graph goes to infinity, who is the bigger bully? The numerator or the denominator? The denominator is the bigger bully. If I plug in 10, it'll be 10 over 100. The bottom's going to be bigger. If I plug in 100, it'll be 100 over 1, 2, 3, 4. 10,000. The bottom is going to be bigger. As this number gets larger, we're going to go to 0. So we know we have a horizontal asymptote at 0. Vertical asymptotes at 1 and -3. So to graph this graph, we can actually now look at our limits. As the graph gets closer to -3 from the right side, the graph shoots up to positive infinity. As the graph gets closer to -3 from the left side, the graph shoots down to negative infinity. As the graph enters from the left-hand side, we said the horizontal asymptote was 0, so we go from 0 to my left limit. Let's check out the next limit at 1. From the right side of 1, we see it's going to be a positive infinity. From the left side of 1, we see a negative infinity. Hey, let me ask you this question. How can I connect this limit all the way to this limit over here? Please don't draw a line. But draw something, remember, like it's almost like an S shape. We have to cross through the hole, and then we can get over here. If you want to be a little more accurate, we can plug in 0, because this is x equals 0, right? So 0 plus 2 over 0 minus 1, and 0 plus 3. That's going to be 2 over -1 and 3. That's going to be -2/3. Totally accurate graph. And then our last part, we had our last limit going to infinity. But remember, we have to end up over here at 0. Here we go. That's the graph you're going to get in Desmos, guarantee. Okay. All right. So A couple things we want to go over. The last part is, okay, so this is what happens at vertical asymptotes. We see what's going to happen on the left and right side. And you can do this without a graph. And that's what one of your homework assignments is going to be today, just doing it without a graph. Now, I'm going to give you one more tricky one. And this one looks like this. 1 over x plus 2, and the limit as x goes to negative 2 squared. Okay, I'm going to square that denominator. So what's the limit? As x approaches negative 2 from the right side of 1 over 1 plus 2, turn x plus 2 squared, and the limit as x approaches negative 2 from the left-hand side of 1 over x plus 2 squared. Now, we could go through the motions. I could draw you a number line and say, hey, this is negative 2, blah, blah, blah. But I want you guys to look at this problem. 1 over something squared. 1 over something squared. Okay, if I plug in negative 2, it's going to be 1 over 0. We know that's going to be infinity or negative infinity. Which one is it? Wait, if it's squared, it's always positive, right? It's always positive. 1 over, it's always positive. That means this is always going to be to positive infinity. Even from the left side, this one should have been, let's say, negative 2.01. This should have been negative. But because we square it, it becomes always positive. So we can use our elements from Algebra 1 about squaring things becoming positive to solve these limits, which is kind of cool. Now, over here to answer this last question, is there a limit as we approach negative 2? No, no limit. Because for us, as limits are approaching the middle, like it should be, you could say infinity, but I don't think we do that. There's no limit here. Because you don't know if which limit is faster. Oh, imagine if this got there first and it's waiting for the second limit. I've been waiting for you for a while. So that's why we don't say it. We do say it can go to infinity and negative infinity from the left and right side. Okay, let's do one more dumb one. Yeah, let's just do one more dumb one. Limit as x approaches 3 from the right side of 1 over, let's do negative x plus 3 cubed. Okay, negative x plus 3 cubed. So I threw a little negative sign here. So from the right side, give me a number on the right side of 3. That's going to be like 3.01, right? 3.01. So because of this negative sign, this parentheses becomes negative. 1 over negative cubed. Look how much math work I did there. You could write 0.000001, I think, right? That's a lot of work. I'm not going to do any of that work. The goal is to not do that work. And this turns out to be 1 over negative cubed, which is a positive over a negative, which is going to be negative infinity. Okay. The last thing we want to cover is really quick, is just end behavior, just as a reminder of what end behavior is. So end behavior of polynomials and rationals. So a quick sum. If I say f of x is equal to x cubed plus 2x minus 4x plus 6 squared, okay, like that. Please understand that when x, the limit, as x goes to infinity, or the limit as x goes to negative infinity of this problem here, you only have to ever look at, oops, this. Oh. Okay, sorry about that. So So what we do here is you only have to pay attention to this guy here, because at infinity, none of this stuff matters. Do you think Bill Gates cares about $6? No. Okay. Do you think Elon cares about this line function? Ooh, it's a line function. Oh, scared. You have x cubed here. X squared? Nobody cares about x squared when you got x cubed in the room, okay? So the point is that we only care about the largest exponent, and that's the x cubed. Now what happens at infinity for x cubed? That's going to be a positive cubed, which is positive infinity. That's all we do. If I say on this next one, a negative cubed, negative, 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 it's going to be a negative infinity. What happens to the plus 6? But doesn't 6 matter? You know what? 6 matters if x was a small number. But at infinity, x is not a small number. Okay? And that's one of the things we have to realize. At infinity, we don't have to worry about the little guy. We just worry about the largest exponent. Okay? So knowing this fact, if I say f of x is equal to negative, let's say 4x cubed minus 2x plus 1, what's the limit as x gets closer to infinity of f of x? Remember, I don't care about the little guy, largest exponent. So if I plug in a positive, it'll be positive, positive, positive. It's going to be a huge positive number, but that positive number times negative 4, it's going to be a negative infinity. Okay? So that's our end behavior. Looking at that in the fast way. And also, we want to go over really quickly our rational rules that we learned from pre-calculus, and let's see if we remember them. So we said, here's our rational. We said, in a way, we said it was a n of x over d of x, which was our numerator and our denominator. Okay? So the idea is the exponent, okay, of the numerator is bigger or smaller than our denominator. Then the exponent of the denominator. Okay, that's the biggest thing. Who's going to be the biggest bully, the top or the bottom? And we have 3 rules to illustrate this. So rule number 1, so I'm going to write this a little differently too. Say x to the n over x to the m, where m is my bottom denominator and n is my top denominator. All right, plus, I want to say nobody cares, but I don't think nobody cares will be good. Plus, just scratch it. Okay? Because we only care about the biggest bully. Just like our last round, we don't care about the smallest bully, just biggest bully here. So first rule is if m is greater than n, then we have a horizontal asymptote at y is equal to 0. Now let me give you an example of that. If I write x over x squared plus 1, okay? At infinity, doesn't the bottom fraction blow out the top because it's going to be so much bigger? And when the denominator is bigger than the numerator, it leads us to 0. Y goes to 0. So no matter what, all we care about is the horizontal asymptote. And you can say, Mr. Go, but what about on the right side or the left side? Doesn't matter. What's the difference between positive 0 or negative 0? Both 0. Okay, so first simple rule. If the denominator has a bigger exponent, our end behavior as x goes to infinity is going to be 0, whether we go to negative infinity or positive infinity. You're going to say this also at negative infinity. Y is also going to 0. Mr. Ko, it's negative 0. Nah, that's 0. Second rule. If m is equal to n if the exponents are exactly the same. Okay, then we're going to have to say this. We divide the coefficients. So I'm going to write this a little differently. We're going to go back up here and add this to your value now. Call this A and B. A and B, just the front coefficients. Keeping this simple. Then then horizontal asymptote, y equals to A over B. It's just a fraction, and many of you guys might remember this rule. It's just a fraction. So in this dumb example, this is going to be a 1 over 1. And this, the limit, as x goes to infinity, of x squared over x squared plus 1, this will be 1. And you want to be able to do this super quickly by looking at the fraction. Oh, the exponents are the same. It's just going to be the front coefficient. Now let me show you guys why. If I plug in 10, this will be 100 over 101. Isn't this about 1? And the same joke as before. If you're a millionaire, at infinity, do you even care about 1? No. The x squared would have blown out any of the other numbers, so we only care about that front number. And millionaires only talk to millionaires. Even if this was y is equal to 3x cubed, oh, that looks ugly, cubed minus 4x squared plus 6x divided by 2x cubed plus 1. Okay, what's the limit as x goes to infinity of y? At infinity, don't talk to me. I don't care. It's just 3 trillion divided by 2 trillion. It's just 3 over 2. That was one of the cool rules. At infinity, you don't care about anything else. You just care about the front coefficient. The last one is, sorry, kind of pushing the envelope here. 3 is, actually, I think I pushed the envelope and I stepped on it. If, I think n was, oh, m was, if n is greater than m, if the top exponent is bigger, no horizontal asymptote. Okay. No horizontal. There is no plane. There is a slanted asymptote, but it follows actually all the rules that we talked about before. So for this rule, plug in infinity. At infinity, wouldn't that be positive infinity? At infinity, wouldn't this also be positive infinity? What is positive divided by positive? At, so that's not right, at the limit. So, you know what? Let's save time. At infinity, y, so at plus infinity, then y would be plus infinity. But I want you guys to watch the negative version. Okay, watch the negative version. Okay, here's the crazy part. Can I do this with negative infinity? Sure you can. Plug in negative infinity and plug in negative infinity. What is negative infinity squared? That becomes a positive. But what is, oh wait, that's just negative infinity. So at x goes to negative infinity, y is actually negative infinity. So I can guarantee you that this graph, no matter what it looks like, will look like this on the right and this on the left.